Hey there guys, so I've got two antennas here, three in total. I've got two 5.8 gigahertz antennas. This and this with its leads came as a kit from Banggood. Now you probably may or may not have been on Banggood and you've seen these as the kits with the leads. This little fella came with this screen, which is the FPV screen for a Syma X5C. It came with a camera, and although this one doesn't have any inside, it's because when this was inside this, it kept overheating, so it wouldn't stay on for very long. But if I take it out, I can run it and there's no overheating issues. I got this from Gearbest and they were good enough to refund me for it, because I said, look, it's just no good, I can't actually use it where I'm supposed to, I've got to take it out of the casing. So I got this, the battery for this was pretty much dead within the first month anyway. That's still up here. I took the leads off in case I need them. I was going to do a little short video on what happens when you pierce through one of these and we could watch it go. I was going to pierce it through and either chuck it in my fireproof bag or just put it in a jar and just video it disintegrating itself and destroying itself. But let's put that to one side. So these two antennas. Now I would have thought that this one would have outperformed this one, but it doesn't seem to work like that for these two antennas, at least for the two that I've got. This one performs really poorly in comparison to this. This I can barely get 300 meters. I can't really go off to the sides at all. It's not very good at all. Not for me, not this one for me. But this one I can do 1100 meters. And then this will start fading the control antenna. So I've not actually managed to take this to its limit. I've had it so when I'm flying and I've drifted off to one side quite a bit, that I start to lose connection signal, and I don't realise that I've disorientated myself that much. I've gone off to the side. I think it's still in front of me, and I thought that this was starting to reach its limit, but it turns out after watching the video back afterwards, I drifted off so far I was actually facing this in the wrong direction. Now I tend to face mine, I screw it in like this and I have it from the bottom facing up, rather than what a lot of people do. So they have it connected and they put it all the way back like this to be facing up. I tend to do mine with just a little bit more, less bend in the cable, going from the bottom facing up. No other reason. It doesn't give me any advantage or any disadvantage, because there's only a few inches difference between facing that way or facing that way. Of course the quad's going to make a lot more difference than that as it's in the air, so no difference whatsoever. Now what I've not done with this, whatever frequency my controller's on, and the batteries are charging at the moment so I can't really look at it at the moment, but whatever frequency my controller's on seems to be tuned to this specific antenna more so than this. This is something I've just thought of this evening while I've been looking at these two antennas and thinking about them, that maybe I need to check different frequencies, because I can adjust the frequencies in my controller and check that across the different frequencies that I'm giving this, I'm tuning it to this, or as it may not be at this minute in time. So that's something for me to look at tomorrow. I've got 3 batteries charged. I'm charging another 2 at the moment. These 3 are charged. I'm just using them as paperweights at the moment to hold down these bends in the paper to make it look a bit nicer on here. So I will do that tomorrow, because I'm not having a very good time with this one at all. And I would have expected this one, because it cost a lot more with this and the other 2 connector wires, pigtails I think they're called, to the SMA connectors. I would have thought it would have outperformed this, but what we're going to do now, and this is a 3 dBi, just what I'm going to do now is I'm going to pull these both apart and have a look inside and just see what they're actually made out of. Not what they're made out of, but how they're made, how they're set up. We'll start with this one because it's going to be the messiest, because it's got more bits. Now, as you can see, look, it's got it's got this plate here. That's what I understand, and from I've scraped a little tiny bit away. I peeled back this this cover slightly. Look, I'll show you. Doesn't bother me, and then you can see there's like silver backs, and so I scraped it away a bit because I understood it's supposed to be copper as a better reflector. And as you can see, look, you've got these two extra plates. Not sure what they're made out of, some sort of fiberglass maybe, but they've got their own copper plates. Copper, it's on the inside, but I just wanted to show you really what it looks like that. Now please forgive if the mic gain goes up and down a little bit. This camera's been a bit weird today. Quite a lot of my electronics have been a bit weird today. I don't know if it's the heat. It could just be me. Let's whip this apart anyway. Now what's going to be the best way? So I want to show you this as it comes off. So I'm just going to loosen just that a little bit. Just going to loosen just that a little bit. And that a little bit. Just so I can unscrew the nuts. Let's get this. That used to be inside my controller. Let's get this off, and we can take this apart plate by plate. I'm just going to keep my fingers underneath just so the screws don't just fall out. So this is the first plate. Now this is the way this would face the drone, this side. Now I presume this is just like copper leaf, let's say. It's not a chunk of copper, it's going to be like, you know, real thin copper leaf. If it was gold, they'd call it gold leaf, wouldn't they? But it's copper. And so that faces downwards. And then you've got three spacers, all being the same thickness, you hope. I'm sure that's just done through a machine, so they should be, at least within a specification of error anyway. And then you've got this extra plate. Now there has to be, I would have thought, some significance between these being round reflectors, if that's what they are, reflectors, and these being square. I don't know the significance of these, why they're square or why they're round. I couldn't tell you. I really couldn't. I have researched, I have looked to try and find information on these, but I find some videos of these being taken apart, but I don't actually find anybody saying why these are the shapes that they are. So we've got some more spacers here, so let's just get rid of them. They're the same as the other ones. And then we've got the screws. Let's just let those drop out. Now there will be no connection between the underside of this labelling cover, the copper backing that's on here, and the front, apart from between this coax and here. Now I don't know if you'll be able to see that, but if I zoom in, you might be able to see some little indents, yeah? And that's how the coax is getting through to the plate underneath. I put a meter on there, on the little bit that I scraped off, and I put a meter to here, and there's continuity. So I know that that's connected to this side, this reflector side. And I know that there's no continuity between the braiding and the signal side. Now from what I understand about these setups, and I don't understand fully, or I'm not going to profess to be an expert or anything like this. But what I understand is we just ignore this top part. I mean, if we just had that bit there, and I hope you can see what I'm trying to show you. If we just had that bit there, so keep that in your imagination for now. So if we just had that bit there, because the way the signal would come in here, it would hit this plate and this plate at the same time and travel down here into the inner part of the coax, the signal part, and that would be considered to be a linear antenna. But because there's these other two plates, and the way that these come in with these extra little bit of much thinner than these, of course, tracks. From what I understand, these act. Now, I only use this word because I've heard it being said, and I can't tell you that I fully understand, even though I sort of do. It's to act as like a resistor, because from what I understand, possibly, if I get this right, this has got some sort of polarization on it, as opposed to it just being linear, where they come in exactly the same time and down there. This is in order to give a time delay between the signals coming in and coming down here. One of these would offer 8 dB gain, and then when you add another, it would offer, another one of these would offer 3 dB gain. So those two together would then be 11 dB gain. In order to get another 3 dB gain, you've got to double the area of receive area, double these pads. So these two, being the double of those two, would then offer another 3 dB gain on top of the 11, which gives you your 14 dBi gain. That's it. That's all I know. I'll share that with you. That is pretty much all I know. And I know, you know, and I understand that the copper part on the back is a reflector for this. So the signal comes in and it gets bounced back as well, and it does all this magic in here. What I don't understand is the role this plays, or this one plays, because if this is copper, in my head, and as ill-informed as it is, if the signal is trying to get through this copper to get to here, won't it be bounced out? If it comes through and gets bounced off the back copper to this, wouldn't this bounce it away? Wouldn't this, and then this one, two of them, bounce it away twice? So you're going to get nothing here. There's nothing going to go through there, because if you face that towards the drone, it doesn't work. It's got to be this bit. But then if you're putting these copper plate things on, it all gets mighty confusing to me, because I just don't know enough. And although I've, you know, watched the videos out there, and I have gone looking, I can't find enough information to clear that up in my head. So if anybody's got anything to offer on this, it would be fantastic, because I would love to know how this works. I knew a fella a long time ago, back in the old CB days, and I'm sure he'd be able to tell me exactly how all this worked. It was what they used to call a rig doctor, and that man knew. I didn't know how much that man knew until I helped him move from his little apartment to a bigger place, and I pulled out a drawer full of electronics qualifications. That man was so loaded with it. I would love to know him today, but as far as I know, he moved abroad and he's out there married and all sorts. But there we go. So that's that one. Now this one here, I think the chap's name is Rocco. He was talking to me earlier, and he's got very similar, it looks exactly the same, patch antenna, the same as this, but it doesn't seem to have as good a time with it as what I do with this one, because I don't have a very good time with this one, but I have a great time with this, meaning that I can't get 300 meters with this, but I can get over 1100 meters with this, and that was with it drifting off to one side. How it would perform for me if I kept the thing in front and I kept this towards a signal being radiated my way, I won't know, because to be honest with you, my control signal was flopping out before the FPV signal was flopping out. I've ordered a 5 dBi control antenna, 2.4 gigs of course, with the SMA male connector here. I've ordered that, and I've ordered it from our friends in China, and hopefully it won't be too long before it gets here. But then I'll be able to see if I can actually test this to its limit, staying on course with a damn craft in front of me going away rather than drifting off to the side. Let's poke this open and see what we got. Now, I've been in this already, because this is the second time I've done this video, because the first time I did it, the up and down on the gain on the audio was so much, it was just annoying me, so I can imagine it would have annoyed you guys. And even the most polite would have been having to hold your tongue a bit, so I don't know, somehow they wouldn't give me that much grace. So let's pop this open. And now I've noticed as well that both of the coaxes on these are the thinner ones. As far as I know, I've got another antenna coming, a Banggood, 2 of them matching, one for the transmit side, one for the receive side, and that's going to have the thicker, I can't remember what number it is, 406 is it? 402, don't know, but it's a different, this one's 3 something on it, I think. So on the inside of there, look, you've got nothing but the fixing holes, so it slots and holes in nicely. So this is the back side. This will have the reflective part on that the coax will be connected to. And on the front side you can see we got this like Wi-Fi logo, whatever that would be called there. So let's pull this out. I've done this a few times now, so I don't need to use a screwdriver on it anymore. Look at the difference there on those plates. Not only are they smaller, the whole thing's smaller. Look, if we just go size to size like that. Oh, if I get that in shot, so tacky everything is. You see there's a massive difference when it comes to the size of those plates. And there's also a difference in the way it's set out. There's no bendy like in this on here. It's just straight through, like a linear fashion. So we're going to have 8, 3, 11, and then double that again. Double the surface area again to get another 3 dBi, because that's what you're doing there. You got 8, you're doubling the surface area, giving you another 3 dBi, gives you the 11, double the surface area again, and you got yourself another 3 dBi on top of the 11, which is 14 dBi. I understand that bit. It took me a few goes though to get that locked in my head, I'm telling you. Thanks RC Model Reviews for that great video you've done on this, explaining the insides of the patch antenna, and I'm probably not doing any justice when I talk about this. Even though yours was basically like this but slightly different. He does explain it well, so I'd say go and check that channel out and have a look at the way he's done his explanation of the patch antenna. That man's in the business, he's been in it for a long time, he knows what he's talking about. I don't. I'm just doing this to have a look at inside mine, see what the differences are, and you know, in case you've got these type of antennas, you don't want to take them apart, you get to see what's inside these ones as well. So outside braid connected to this plate out here, and the inside bit comes through and is connected, and by the looks of it, this is in a linear fashion to this. So I'm wondering why. Is it maybe because the frequency that my handset is on is better set up for this receiver, this antenna, than it is this? I'm not going to know that until I get out and I start changing the frequencies with this, and that'll be easy enough for me to do, because I should be able to take the drone out set it down when I start to lose a bit of picture, and then start changing the frequencies and see if it gives me a better image, and then take it out until I start losing that signal again, and change the frequencies again until I hopefully get a bit of a better signal, and just do it like that. And if all goes wrong and I can't see it again, and I can always hit return to home maybe, or I can just swap out the antennas, put this one on, get the signal back and FPV back. Won't be a biggie. There you go. Both of these coaxes are pretty much the same size. There is a slight bit of difference there. Not sure, I don't think there's enough difference there to make a difference particularly, but maybe there is. Maybe these things are so calibrated that it does make a difference. I don't know. Maybe if somebody's got one of these XDMA model, maybe they could do a measurement, and we could compare and see if there are any differences, especially if yours works well, or if you're using it with a Hubsan, what frequency are you using it with? And I could maybe adjust mine to that frequency and see if this makes any difference there. I think that's quite interesting, the differences between these two. They're both 14 dBi, they're both 5.8 gigs, but we know that's over quite a bit of a spectrum of 5.8 gigs on both. And they can both be tuned in or out depending on the frequency of receiving on the handset, which you can adjust. And that will be an experiment I do tomorrow that I hadn't even thought about until this evening, until I started looking at these and thinking about them. There you go. That's it, that's all I got for you on that. I hope, that's become of an interest to somebody and might help somebody out. Rocco out there, if maybe you might want to change the frequency of yours on your handset. I'll actually stick it in the description or something, the frequency mine's on at the minute, and you can compare it to yours on your handset. And if yours is the same as this, because look, it's dead easy to take apart, as you can see. If it is the same as this, maybe try it on that frequency and see if it's any better for you, mate. Okay guys, well, I'll catch you in the next one. Hey, if you like it, give us a thumbs up and I'll just carry on doing more stuff like this. Till the next time.